Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to solve systems of linear equations using the method of elimination. This method is also known as the method of linear combination and addition or subtraction. All right, before we get started, let's go over the strategy that we're going to be implementing today in solving linear systems of two equations using the method of elimination. Okay, so first of all, you want to place both equations in standard form, namely ax plus by equals c form, if it's not already in that form. Okay, and then you want to go ahead and identify the variables that you're trying to um, that are opposites of each other. Okay, so either the x's or the y's are opposites of each other. If they are not, you will try and make either the x's or the y's opposites of one another. And a hint here is if the values are different, you want to convert both of them to their LCDs. Okay. Now, after you've created an opposite with either the x's or the y's, you eliminate that variable by adding the two equations. Okay, and then you'll be left with one variable, or you could be left with none. But if you're left with one variable, isolate that variable, and that will be your first solution. And then to finish up, you plug that answer back into the first or second original equation to get your second solution. Okay? All right, so this is just a brief summary of the steps I went over. We're going to be using that to guide our problem solving process. Okay, so the task is to solve by elimination. All right, for problem one, we have the system negative 4x plus 6y equals negative 22, and negative 2x minus y equals positive 1. Okay, so now first thing you want to do is make sure that they're both in standard form. They clearly are in standard form. Forget about the minuses here, okay? It doesn't really matter in this case. Now what we're going to do next is look at the x's and the y's and ask ourselves, which of them are opposites? These are not opposites. These are not opposites either. So the next question is, which of them is easier to convert into opposites? So if you look at the x's, what you want to do is, since they're different, is you want to convert these two into the LCD of the two numbers. Okay, and then for the 6, there's a 1 here, so you want to find the LCD if you want to eliminate the y's. So let's just go with the x. So what is the LCD of 4 and 2? Basically the smallest number that these two evenly divide, which is 4. Okay, so the goal here is to make one of these equations 4 and the other negative 4. This is already negative 4, so we might as well try to convert this to positive 4. So what should we multiply this equation by to make it into positive 4? Let's rewrite the equation. So we have negative 4x plus 6y equals negative 22. And then we have negative 2x. I'm just rewriting the problem. Minus y equals 1. All right, so I'm going to call this equation 1 and this equation 2. So what I'm going to do is I'm going to multiply equation 2 by the number that will make this the opposite of 4. So multiply it by negative 2. Okay? If I carry out that multiplication, my system now becomes negative 4x plus 6y equals negative 22. And this is where you want to be really careful. Ensure that this 2 is distributed across the entire equation. Okay? So this now becomes positive 4x. Distribute this to this plus 2y. And then distribute negative 2 to 1 minus 2. All right, so what we have just completed is steps number 1. We identified the term we wanted to eliminate. We focused on the x's. That's why we did the LCD of their coefficients, 4 and 2. And guess what's going to happen? Now that we have opposites, we're going to combine the two equations and check this out. Since these two are opposites, when I combine them, they add up to 0, and we're left with 8y equals negative 24. So what have we just accomplished? We have accomplished elimination. We have eliminated one of the variables, okay? Now, step 4 involves us solving for the remaining variable, isolating it. That will be our first solution. So divide both sides by 8, and your final result will be y equals negative 24 divided by 8 is negative 3. All right? Now, we have one answer. To get the second answer, we're going to advance to step number 5. We're going to substitute this answer into equations 1 or 2 and solve for x. Okay, it doesn't really matter which one we want to use. Let me use the second one. So what I'm going to do is I'm going to substitute negative 3 for y in equation 2. So what does that yield? It gives us negative 2x minus negative 3 equals 1. Okay, so you have negative 2x minus times minus makes this plus 3 equals 1. To get x isolated, we subtract 3 from both sides. That leaves us with negative 2x equals negative 2. Divide both sides by negative 2. And your final answer will be x equals positive 1. Okay, so your solution to this system of equations is x equals 1 and y equals negative 3. Okay, let's go ahead and try question number 2, another example. So question 2, we have the system negative 8x plus 2y equals 1 and negative 20x plus 5y equals 5. Okay, now let's see, which one do we want to eliminate? Do we want to eliminate the x's or the y's? If you inspect the two variables, they're not, we can't see any ones that are identical, so we have to carry out some multiplication to make them into the desired number. So what we're going to do, let's call this equation 1, equation 2. Let me show you the LCDs, okay? So let's find the LCD of the x's, which is so I'm looking at these coefficients right here. So I find your LCD of 8 and 20. Forget about the sign for now. The smallest number that 8 and 20 go into is 40. Okay? So you can make these to 40, or you could shift your attention to the y's and then find the LCD of 2 and 5. The smallest number that needs to go into is 10. Okay, so pick whichever one you want. Whichever option that you select, it looks like we're going to have to multiply both equations by something, since 40 doesn't match any of the x coefficients and 10 doesn't match any of the y coefficients. Okay, so how about we eliminate the y's? To do that, I want to make the first equation to have the y term to have a coefficient of positive 10, and then the second one to have the coefficient of the opposite of that, namely negative 10. So what I'm going to do, let me rewrite it again. We have negative 8x plus 2y equals 1, and negative 20x plus 5y equals 5. So I'm going to multiply the first equation by 5. The goal is I want to convert the coefficient of y to the LCD. Okay, so this is for the y's right here. And then that's going to make this 5 times 2 positive 10. So this needs to be negative 10. So I'll multiply it by negative 2 to get that goal accomplished. So what becomes of our system? We're now going to have distribute the 5 across every single term. Negative 40x plus 10y equals 5. The second equation, distribute negative 2 across all terms. You're going to end up with 40x. Remember, minus times minus is plus. Minus 10y equals negative 10. Okay, now what we're going to do is combine both equations. So the goal is to eliminate y, right? because that's what our goal was. So we see the y's are opposites. But wait a minute. In the process of creating opposites with the y's, we created opposites with the x's. So when you combine these two equations on the left side, you end up with 0. This is a possibility, okay? On the right side, 5 minus 10 is negative 5. Anytime you have a situation where all the variables cancel out on the left, the right side, you want to carry out a comparison. Do you end up with a true or a false statement? Okay? Question, is 0 equal to negative 5? Is 0 ever negative 5? Never, okay? This statement is false, so you have no solution to this system of equations, okay? Had it been you had something like 0 equals 0, guess what? You will have infinitely many solutions because 0 is always equal to 0. That's a true statement. But anytime you end up with a false statement, your answer is going to be no solution. Okay? So that's the answer to question number 2. All right, let's take a look at question 3, the last one in this review installment. What if we are to solve the system negative 3x minus 5y is equal to 10 and 10x plus 3y is equal to negative 6. All right, now, let's see. Let's call this equation 1, equation 2. Now, the two equations are already in standard form, so step 1 is done. Now, I want to identify the variable that we want to eliminate, the x's or the y's. If you look at these two numbers right here, it looks like none of them is equal to their LCDs. Let me just focus on the x's. So what is the LCD of the coefficient of the variable terms? The coefficient of the x variable. So what is the LCD of 3 and 10? The smallest number that these two numbers go into is 30. Okay? So the goal is to make one 30 and make the other the opposite. Since this is already negative 3, we might as well make this negative 30 and then make this one positive 30 for the x. Okay, so let's rewrite the equation. Negative 3x minus 5y equals 10. And then 10x plus 3y equals negative 6. So I will multiply the first equation by what? I need this to become negative 30, so I multiply by 10. Okay? Now I want the coefficient of x in the second equation to be positive 30, so I multiply by 3. Now when I multiply and distribute, that gives me negative 30x minus 50y equals 10 times 10, 100. Second equation, 30x plus 9y equals 3 times 6, 18, negative 18. Okay, so I need the x's to be eliminated. So we created opposites. If you look at the x's, the opposite of negative 30 is positive 30, which is excellent. Now we're going to combine both equations so that these ones cancel out and you're left with negative 50 plus negative 50 plus 9 is negative 41y equals, if you combine these two, 10 minus 8 is 2, 9 minus 1 is 8, positive 82. So we just eliminated our variable x. To finish it off, we have to solve for y, divide both sides by the coefficient of y, negative 41. And you end up with y equals 82 over 41 is negative 2. Okay, so we just solved. Now to finish up, we're going to substitute this result into any of the first two original equations to solve for x. Okay, so we're going to substitute negative 2 for y in which equation do we want to use? Let's use the first one. It doesn't really matter which one you use, all right? So we have negative 3x minus 5 times negative 2 equals 10. Negative 3x minus 5 times minus 2 is positive 10. equals 10. I will subtract 10 from both sides. The goal is to isolate x upon substitution. So we add downwards, and then we have, what do we have? The 10s cancel out to 0. We have negative 3x equals 0. 10 minus 10 is 0. Divide both sides by negative 3. And the goal is to get x isolated, which we have just accomplished. 0 divided by negative 3 is 0. So the solution to this system is x equals 0 and y equals negative 2. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful to you, to give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions about the content we just covered, just place your question in the comments section below, and we'll be glad to support you. Don't forget to subscribe for more. More clips can be found on mathgotserved.com. Thanks again for watching, and have a wonderful day.